With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi friends, the question is sulfur exits in more than one solid form. So the stable form at room temperature is rhombic sulfur. We know that because most stable form of sulfur is rhombic sulfur. But above room temperature, the following reaction occurs. That is, sulfur rhombic will get transferred into sulfur monoclinic. Okay. So if DeltaH, that is change in enthalpy value is 276.144 joule at 298 Kelvin and 1 atmospheric pressure, and change in Gibbs free energy value is 75.312 joule. Calculate entropy change at 298 Kelvin. So that is the first one. Second one, assume that enthalpy change and entropy change do not vary significantly with temperature. Calculate temperature equilibrium temperature, the temperature at which rhombic and monoclinic sulfur exist in equilibrium with each other. So the question is very simple, that they gave the values of enthalpy and the Gibbs free energy. We have to calculate the entropy value for the transformation of rhombic sulfur to monoclinic sulfur above the room temperature. Okay. So that is the first one, and the second one is we have to assume that enthalpy and entropy change do not vary significantly with temperature. Okay, so we have to calculate the equilibrium temperature where rhombic and monoclinic sulfur both form exits in equilibrium with each other. So we have to calculate the TEQ value. Okay, so we have to calculate both DeltaS and TEQ value for this transformation of rhombic sulfur to monoclinic sulfur. Okay, so let's discuss it one by one. The first one is we have to calculate the DeltaS value at 298 Kelvin. So the temperature here is 298 Kelvin. Okay, and then Gibbs free energy change. Free energy change value is 75.312 Kelvin. Okay, sorry, joule. 312 joule, and then DeltaH also given, that is enthalpy change in enthalpy value is equal to 276.144 joule. Okay, so now we have to find out the DelS value. Okay, DelS change in entropy value we have to calculate. So now we have to apply all the values by using the formula DeltaG is equal to DeltaH minus T delta S. Okay, so now we have to find out the DeltaS value. So the formula will become like DeltaS is equal to DeltaH minus DeltaG divided by T, where T is the temperature. Okay, so now we have to apply all the given values in the above formula. So by applying it, we can find out the value of DelS. Okay, so DelS change in entropy is equal to DelH value is nothing but 276.144. 276.144 minus DelG value is 75.312. 75.312. So 75.312 divided by 298 Kelvin. Okay, that is the temperature given. So 298 Kelvin. So by that is joule, and the unit is joule per Kelvin. Okay. So now when we simplify the above equation, we will get DeltaS value as 0.674 joule per Kelvin. Okay, so this is the entropy value that we have found out. Okay, by using the given values of Gibbs free energy change, temperature, and enthalpy value. Now we have to calculate the equilibrium temperature. Okay, TEQ. So B TEQ. So under equilibrium condition, that is under equilibrium condition, the sulfur rhombic, that is sulfur rhombic will be equivalent to sulfur monoclinic. Okay, so that is the two forms of sulfur. So monoclinic. So the del G value will be, that is Gibbs free energy change will be 0. Okay. So then the formula will be like del G is equal to del H minus T delta S. So here del G is equal to 0. So del H minus T del S is equal to 0. Okay, 0. Then we have to find out the equilibrium temperature. So TEQ, that is equilibrium. TEQ is equal to del H here minus, so it is del S. Okay, del H divided by del S. So del H is upon del S. That will be equal. Del H value is nothing but 276.144. So 276.144, and del S value we have calculated in the above section A. So 0.674. So 0.674. So when we calculated this, we will get 409.70 Kelvin. Okay, so that is the equilibrium temperature when rhombic and monoclinic sulfur are equilibrium with each other. Okay, so therefore the answer is, A del S value, entropy value will be equivalent to 0.674 Kelvin. Okay, sorry, 0.674 Joule per Kelvin. Joule per Kelvin. And temperature equilibrium B, equilibrium temperature is equal to 409.70 Kelvin. Okay, so this is the answer for the given question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.